The roots of the human race are shrouded in mystery, lost in the depths of prehistoric time. For although every school kid knows that we evolved from the apes, the reality is that almost nothing is known about our earliest beginnings. But in October of the year 2000, here in a remote corner of Kenya, an extraordinary find was made.
It was instantaneous when we found this. It was really the few seconds that followed. We knew this is going to change things.
This could be the oldest human ancestor ever discovered.
We know very little about this time period, so no matter what it is, it's very exciting.
We may at last have found the animal that set us on our path to humanity.
It's the only way we're going to piece together our ancestry and understand where we came from.
This may be the ape that learned to walk. It is February 2001, and a news conference is called to announce an amazing discovery. British, French, and Kenyan scientists have found what they claim is an ancient human ancestor, an animal that may come from the mysterious point in our evolution when we descended from the trees. If they are right, then the implications are enormous. Nothing like this has ever been seen before. Martin Pickford, British-born geologist and paleontologist, has been searching for fossils for over 30 years. For him, discovering what may be an early human ancestor is the find of a lifetime.
Being a scientist, and I try and be a good scientist, it's an ongoing thing. To make a really big breakthrough, obviously doesn't happen that frequently, and when it does happen, it's quite exciting. Yeah.
Brigitte Senou is a specialist in fossil morphology, or the study of the shape of ancient skeletons. She and Martin are based here at the French National Museum of Natural History, one of the oldest museums of its type in the world. By finding such significant bones, they are on the brink of a revolutionary and controversial new theory of how we came to be.
It's not an easy position, but don't forget that science don't proceed or don't get better with established ideas. You have to have challenge.
The story starts some 6 months earlier here in the Tugen Hills, a remote and rugged area of northeastern Kenya, a part of Africa that's often called the cradle of humanity. Kiptalam Cheboy, an experienced fossil hunter, made an incredible find.
I was slowly walking along the ground. Actually, this ground was once a stream. So, as I looked closer, I saw something that struck me. When I looked more closely and even turned it over, I could see they were human teeth. When I saw that, my whole body was filled with excitement. If I had jumped for joy, I would have hit the sky.
These fossilized teeth that look strangely human were the start of something truly extraordinary. Kiptalam was working for the Community Museums of Kenya, an organization that has close ties with the French Museum. Martin Pickford and Brigitte Senou traveled as quickly as they could from another dig in Uganda. Almost as soon as they arrived, they were to make discoveries of their own. Discoveries that would be more and more intriguing.
When I found it, all you could see was the head like that. The erosion had removed the sediment from around it. And I picked it up, and actually this bit stayed in the ground, only the head came up, but I could see this break here. You can see the crack. So I dug carefully, and I found this bit, and then this bit was attached, and then there was a third bit. And then this, unfortunately, was missing. The lower end of the femur was missing. And that would have been beautiful to have that, but unfortunately it's not there. And we dug all this trench looking for the rest of it, but never got it.
What Martin had found was a femur, or thigh bone. This too appeared to be uncannily human. Might this be a hominid, an early form of man? There was still more to come. Brigitte made another breakthrough when she found an upper arm bone, or humerus.
I was walking here in the sun. It was lunchtime. We were going back to the camp. And sticking out of this area was a little piece of bone like that. And I picked it up, and it was obvious to me from the morphology it was a piece of a humerus. And it took me about a week to stick all the pieces together.
Within 2 weeks, the count stood at 13 fossil fragments from 5 different individuals of a creature new to science. But what was really important was that they appeared to be far older than any comparable find. So old, in fact, that they could describe the very genesis of the human race, the very roots of the family of man.
It stretches human history way back, and we're seeing the opening chapters of human origins here.
Because the discovery was made in the year 2000, the press dubbed the find the Millennium Man, but its real name would have to wait until later.
It's now being christened scientifically as Ororin tugenensis. Ororin is a Tugen word for the original man, and they have a legend in their mythology about the original inhabitant of this region, and he's called Ororin. So this name was suggested to us by the local people, and we thought it was quite a pleasant name, because aurore in French is dawn, and that also is fairly appropriate. Unfortunately, aurore in Italian means horror, which is not so good. But Ororin is now the official scientific name for this species, or the genus, and then Ororin tugenensis for the species.
But were they jumping the gun? Was it really as old as they thought? Fossils are made when minerals replace organic matter, taking on its shape, literally turning the bone into stone. Carbon dating this material is impossible, so how can they be sure of their age?
We can't actually date the fossils directly themselves, but what we can do is date the strata in which they occur, and then extrapolate that date to the fossil.
The geology of this region helps. The area is known as the Lucano Formation, an ancient lake basin formed by a giant lava flow that poured from one of the massive volcanoes that are dotted around this part of eastern Africa.
That lava flow is huge. It extends for 50 or 60 kilometers north-south and about 60 or 70 kilometers east-west. And it formed the floor of this lake basin where these sediments, the Lucano Formation, accumulated.
This lava is called trachyte, above which the sediments were formed. Then a second flow of another lava, basalt, created the icing on this geological layer cake. The lavas can be dated, so anything found in the middle, such as Ororin, must come from a well-defined slice of prehistoric time.
So we're basically in a kind of sandwich with trachyte dated at 6.2 million years below, and these basalt lavas at 5.65 covering the sediments.
6 million years, even if only a rough date, is an extraordinary age for a hominid. To understand why, take a single modern human and place a parent behind him, and then a parent behind that, and so on. And only then does the true scale of the evolutionary process start to become clear. generation after generation stretch into the past, forming a queue of spectacular proportions. The first of our kind, the modern Homo sapiens, are 100,000 years old, and would be 5,000 generations, or about 3 miles down this line. Earlier species, such as Homo habilis, the first of our ancestors to use tools, are much older, at 2 million years, or nearly 60 miles away. But as we get further and further back in time, the picture starts to become obscured. And until recently, the last known outpost was an animal that lived between 3 and 4 million years ago, or 120 miles into the past. It goes by the tongue-twisting title of Australopithecus afarensis. When the skeleton of this animal was first discovered, it was given a rather more catchy name, Lucy. And the man who found her was Don Johansen.
Here was a specimen that opened up for all of us, but especially me, an exceptional opportunity. An opportunity to describe a new species of human ancestor. Not only was it an associated skeleton, bits of arms associated with bits of legs, a pelvis, part of the rib cage, part of the skull, a complete lower jaw, but it was more than 3 million years old.
At the time, Lucy was both a revelation and a sensation. And to this day, she is perhaps the most famous single skeleton in the world.
She has continued to play a very pivotal role in the profession as a benchmark by which other discoveries are judged.
But Lucy is a mere juvenile compared with the claims being made for Orrorin. For if it is 6 million years old, it would at last give us a glimpse into our most distant past.
This is a period of time from which we have 3 or 4 fossils that you could fit into the palm of your hand. And anything that would be found in this time period of 5-6 million years has to be important.
With so much at stake, it's crucial to refine the date of the find. To do this, the team have invited a group of scientists from the University of Shimane in Japan to try to get a more precise figure for the sediments in which Orrorin had lain for so long. There are several methods, one of which uses the way the Earth's magnetic field changes over time. First, they measure the precise orientation of a sample, using an extremely accurate compass. It is then carefully marked before being taken away for analysis. Inside this rock, tiny magnetic crystals form, and as they do so, they all point in the same direction, in just the same way as the compass being used to mark them. However, every few 100,000 years, the Earth's magnetic poles switch places. South becomes north, and north becomes south. And this causes the crystals in the next layer of stone to form in the opposite direction. Over the millennia, a unique magnetic fingerprint is left behind. And this enables the rock to be dated. The results will take some time. But first, there is one disturbing possibility.
I actually had nightmares for the next about 2 weeks, thinking, are these things really as old as 6 million years? There has been histories of discoveries in Kenya in particular, but elsewhere in the world, where the discoverers claimed they were very ancient, and they turned out to be much younger.
Because the site is a dried-up watercourse, it could be that the bones have been simply washed there from much younger rocks. This would put the whole find in jeopardy. The spectre of displaced bones is one which haunts all fossil hunters. But there is a way to be almost certain that the fossils do come from the sediments in which they were found. And that is to look at the huge variety of other creatures that accompanied Millennium Man's remains.
In the Lucano Formation where we found Orarin, we also found other mammals, such as elephants, horses, hippopotamus, pigs, and so on. And by the evolutionary stage of those creatures, those fossils, we can also guess the age. And as soon as we found Orarin, we looked around and found other fossils, and we could say straight away, yeah, this is late Miocene in age, so it's got to be around about 6 million years.
The fossilized remains of these animals' ancestors have already been accurately dated at other sites. And by finding their remains here, the indications for Millennium Man are good. In addition, all the fossils are encrusted with a coating that derives from freshwater algae. So they are clearly from the same site. But confirmation comes with the results from Japan. Millennium Man is between 5.8 and 6.1 million years old. This find has the potential to change much of what is known about how we came to exist.
You're seeing a picture which nobody ever saw before. Previously, the oldest known hominid was about 4.2. Now we're at 6 million.
I think most people who are not involved in the search for discovering these important fragments of our ancestry, the thing that they don't understand is how difficult it is. How extraordinarily, how remarkably difficult it is. It makes looking for a needle in a haystack easy, but when it pays off, it has extraordinary consequences.
So what was this mysterious creature like? And more importantly, can we be certain that it really was our ancestor?
Are we looking at an ape, really literally an ape that stood up?
Orarin is so old that it poses a huge challenge for the scientists that found it, because evolution on this scale is a staggeringly complex process. Darwin's theory is not about individuals, but populations, millions of individuals evolving over time. The populations split to form new species, and these split again, and again. So putting any one find in its correct place in this convoluted tree would seem impossible.
We're really dealing with an infinitesimally small, and we hope representative, part of the fossil record, and trying to draw out details about human evolution from those few remains.
But are we talking about human evolution? How can we tell, given this incredibly complex picture, that Millennium Man is related to us at all? The further back we go, the more difficult it becomes. But there is one remarkable ability that modern humans possess. A feature that distinguishes us from all other primates. Something so profound that it might show up even in our earliest ancestors. We walk on 2 feet. We are bipedal. Brian Richmond is an expert in bipedalism from the University of Illinois.
Walking on 2 legs is a thing that defines the human family tree. Not the things we might think of, like the ability to speak, the ability to create art or abstract thinking. In the early fossil record, we don't see evidence of those things, but we do see evidence that they're walking upright. So what we look for in the earliest human origins is evidence of this upright walking.
If Orarin walked bipedally, it is almost certainly our earliest ancestor. But because it's 6 million years old, it would also mean that bipedalism itself is far older than had ever been realized.
Making the claim that any animal this age was walking upright is an incredibly important conclusion for paleoanthropology. It's a very important issue. So we'd like to have the entire skeleton, or at least a good portion of the lower limb, to be able to make this conclusion. Unfortunately, for the Auroran remains, we don't have the knee joint.
The lack of this vital joint is a problem, because the knee is the easiest way to tell if an animal walked on 2 legs or 4. Because humans walk upright, our knees are specially adapted to give us a smooth and efficient stride. Apes, on the other hand, have their knees far apart, and this difference between the two shows up in the shape of the bones.
If you imagine a human standing there like I am now, you've got your body weight coming down onto your hips. It's going down into your thigh bones, which are angled into the knee bone, the knee joint, and then straight down to the floor. And this is important because it makes for smooth walking rather than walking like a chimp with a lot of lateral movement. A human can walk with almost no movement of his hips. So you've got the whole of your body weight coming down through 2 joints into the knees and straight down. And for that to happen, the thigh bones have to be angled in humans.
This angle shows up when the knee joint is placed on a flat surface. If the bone leans outwards, as with this human bone, the animal is certain to have walked on 2 feet. Of course, this crucial test cannot be applied to Auroran. But there might be some clues in the bones they do possess.
Bone is very much a living tissue. It's very dynamic. So in a bone, there's a little bit of a history of the activity of what happened in that animal. And that's what we'd like to get at eventually, is to look inside these bones for clues as to how these bones were loaded when the animal was alive.
A tiny detail on the surface of the thigh bone may give a glimmer of hope.
This is the femur of Auroran, and there is one feature which has been linked with bipedalism, is this groove here, very well marked, for one of the ligaments of one of the muscles, which helps to keep the leg towards, bring the legs towards the body.
This muscle runs from the back of the thigh bone and connects to the front of the pelvis. In a 4-legged animal, it has a straight path, but in a biped, the joint is extended so that the muscle becomes stretched and is wrapped around the neck of the femur, forming a groove in the bone.
If that groove is present, as it is in Auroran, there's a suggestion there that the hip acted in a way very similar to our own, meaning that this creature was bipedal. But it can occur from time to time in other primates. It's seen sometimes in gorillas, it's seen sometimes in even New World monkeys. So that there's an indication there that this was a biped, and we're going to have to wait until more distinctive or diagnostic anatomy is discovered.
Finding just such a piece of diagnostic anatomy is extremely difficult. But thanks to the extraordinary detail preserved in the 6-million-year-old fossils, there is a way to discover if Millennium Man was indeed our ancestor. The secret is hidden in the neck of this one femur.
Since we bear our weight on the hip joint, that weight causes the neck to bend down, creating stress on the top and the bottom of the neck. But there's also a muscle that pulls on this bone right here, and that reduces the stress at the top, but adds more stress at the bottom.
In a bipedal animal, the underside of the neck becomes thicker to support the extra weight, and this hidden feature can provide the conclusive evidence needed by the team.
So if Auroran has thick bone on the bottom and thin bone on the top, then it would provide really good evidence that this thing walked on 2 legs. That inside of the bone and that pattern tells us what the animal was actually doing with its limbs while it was alive. Now, we can't see that with the fossil itself. We'll have to see X-rays or CT scans of the inside of the neck to be able to tell.
As part of the investigation, the fossils are brought to a hospital in Toulouse in France. Here, a CT, or computer tomography scanner, a device normally used to diagnose illness, will produce a three-dimensional X-ray image that shows their hidden structure. These are consecutive slices through the top of the fossilized femur. First, they show the ball, which appears as a circle. And then, as we descend into the neck, the amazing level of detail in this ancient thigh bone becomes apparent. Every hollow, every ridge is there, just as it was in the living creature. The computer builds a three-dimensional model of the find, which can then be sectioned to reveal the thickness of the bone in the crucial area, the neck that took such a large load as the animal moved. Here at last is the vital evidence. Thicker bone on the underside of the neck, there to support the weight of an early human as it walked on 2 feet.
Oranus is something apart from the apes. Walking, running, standing was a major part of the repertoire of this animal, or this creature, and it shows in the bones. It was adapted for that kind of behavior, and it shows that adaptation in its bones.
It is likely then that Orarin tuganensis was a creature that is ancestral to each and every one of the 6 billion modern humans on the planet today. Say hello to your grandparent. With the discovery of Millennium Man, scientists from the French National Museum of Natural History can at last get a glimpse of the species from which we are all likely to have descended.
It's about the size of a chimp, a modern chimp, but its legs were probably longer than a chimp's legs. If you see one walking around or in its environment, you wouldn't have said, "Ah, there's a man or a woman." You'd have said, "There's something a little bit like a human, but not really like a modern one."
Piecing together an entire animal from just a few fragments of bone is an enormous challenge, but the teeth are an excellent starting point. Gary Schwartz is a specialist in ancient teeth at the George Washington University in the USA.
One of the really interesting things about teeth is that they are the only part of the skeletal system that comes into contact with the outside world on a daily basis. Now, what's interesting about the Auroran find is the back teeth tend to have features that seem to resemble the modern human condition, while the front teeth tend to have features which resemble modern chimpanzees.
In a 6 million year old animal, scientists would expect all the teeth to be ape-like, and yet Millennium Man's back teeth seem to be surprisingly similar to our own. They are small, like ours, and the CAT scan shows that they have thick enamel, the tooth's tough outer coating, again, just like us.
The shape of teeth tells you a lot about the food that that particular animal is eating. An animal that eats mostly leaves tends to have teeth that are very sharp and crusted, and those sharp crests tend to slice through the tough leafy material. On the other hand, animals that eat lots of tough, hard nuts and seeds have low, flat teeth, which are used to pulverize and crush those seeds.
Millennium Man's teeth are of these low pulverizing type, And so, like us, it was probably an omnivore, eating whatever it could find as it foraged for food. Nuts, berries, fruit, and insects were probably the main ingredients of its diet. Given its similarity to humans, it might also have eaten meat. But what of its other behavior?
These discoveries of aurorin are very fresh. They're very recent. We don't know much about the broader picture in terms of how they lived and how they made their living. But I suspect they weren't solitary creatures. I suspect that they lived in some sort of a group, probably in multi-male, multi-female groups.
The evidence that they lived in mixed sex groups comes from the study of our modern cousins. Virtually every living primate displays a similar sort of social behavior, and researchers are only just beginning to understand the complex societies formed by the higher apes. Since it is so widespread, there is no reason to suggest that this is a recent development. And so aurorin was almost certainly a social beast, even if it had yet to develop in other ways.
This is certainly a long, long time before the manufacture of stone tools, which don't really appear in the archaeological record till about 2.5 million years ago. So these are pre-stone tool makers by a long shot. And what is, I think, most important is the evidence that comes from the associated animal fossils.
Of the huge number of other fossils found near aurorin, most were of animals that live in forests. Colobine monkeys and small deer seemed to be particularly common, and there was certainly plenty of water around too.
But it's the same old story. You've got lots of impala and quite a lot of colobus monkeys.
Yeah.
So it's...
Mind you, we got a lot of hippos as well, huh?
Well, there's hippos and there's crocs and snails. There's freshwater snails here.
Yeah.
But I
we
think...
we have some more because I asked the guys to collect them specifically. So
Yeah.
we should have it back. Alors ça, c'est le...
This paints a picture of an environment where trees played a major role, and once again, aurorin's remains can help us work out how it lived. This humerus, or arm bone, shows that Millennium Man was a good climber. The large flare at its lower end providing the attachment for the powerful arm muscles that a tree-dwelling animal needs. The finger bone is curved, a feature that all modern apes share, because permanently curved hands are good for holding on to branches.
I suspect it might not have been unreasonable to think that they may have made nests and slept in the trees. Chimpanzees certainly do that, and being off the ground would have added an additional element of safety.
Aurorin would definitely have been on the lookout for predators, because we have the evidence that sometimes the predators won. These shallow depressions are tooth marks, probably from an ancient species of big cat.
It looks as though the aurorin fell prey to some carnivore on a reasonably regular basis. We found the finger bones of a large carnivore, which are slightly larger than leopard, and then we found one of the teeth, one of the carnassial tooth, which is the razor-like tooth that is used for shearing flesh. The carnivore, like a leopard, would fit the bill because it's not only preying on ground animals like impalas, but it's also getting colobus monkeys from the trees and maybe aurorin from the trees or from the ground. Then bringing them to a central place, maybe to its favorite tree where it stores its prey up, hanging the prey up in the trees. And that's why there's such a concentration there.
By gathering its prey to one particular place, an ancient predator unwittingly provided us not only with the evidence of our earliest known ancestor, but also with the answers to some of the toughest questions in all of evolutionary science. How and why and when did we descend from the trees? The way in which we move our bodies, standing and running on 2 feet, has been one of our defining features since we descended from the trees. But in fact, bipedalism is one of the most puzzling aspects of the human race.
Bipedalism is a very rare thing to see in mammals, even in animals as a whole. We know birds walk on 2 legs, but there's a very compelling reason. They have wings, and their upper limbs then are so specialized that they can't use those limbs for weight support, so they walk on 2 legs. If humans had wings, then we would have the answer right there, but we don't. So there must be some other very compelling reason for humans to have begun walking on 2 legs.
The discovery of Orrerin tuganensis, or Millennium Man, proves that this peculiar trait is almost twice as ancient as had been thought. Not only is it very rare, it's also very, very old. What advantage could this strange stance give an animal so that 6 million years later, its descendants would still be moving in the same way? One answer to this difficult problem uses a high-technology field of research. Mark Raybert is an expert in robotics, and his work gives him a unique insight into what might have caused Millennium Man to use 2 feet rather than 4.
We're very interested in the relationship between the robots we build and biology, how people and animals work when they locomote. And the relationship between those has 2 parts. There's what looking at the knowledge about animals tells us when we're trying to design robots. But there's also an opportunity to use what we learn about building robots to help in understanding how people and animals work.
Developed at the Massachusetts Institute of Technology in the USA, Mark built some of the most extraordinary striding robots ever seen, and with a variety of layouts. Some were bipedal, while others were quadrupeds. And this innovative technology hints at what may have driven evolution millions of years ago.
One of the things we found out is that it was much easier to build a robot with fewer legs than with more legs. So a biped was much easier to develop and to make work than a quadruped, largely because the complexity of coordinating the legs was reduced, the mechanical complexity was reduced by not having all the additional mechanisms and actuators.
A 2-legged animal such as Orrerin has some clear advantages over a 4-legged one. With fewer limbs to control, it can transport itself successfully, yet use less of its body to achieve the task. It also uses its natural instability to its advantage. It's highly maneuverable and extremely agile. On top of this, of course, the animal is able to use its hands at all times. It's probably a combination of all these advantages that allowed Millennium Man to survive and pass his unique adaptation down to us. But bipedalism brings a new set of problems. An exceptional sense of balance becomes vital.
In order to achieve that, you have to have a control system that can maintain its balance when just 2 feet are on the ground or 1 foot is on the ground, and when it's running when no feet are on the ground. And so that's a big challenge.
So how did our ancestors learn to balance and to stand up? What could have caused their bodies to change shape so dramatically that they could take advantage of the upright stance? The conventional explanation centers on a huge environmental change that took place here in Africa, deep in the past. "10 million years ago, equatorial Africa was covered with thick forest. But then, the land in the east began to rise due to tectonic activity in the Earth's crust. As the land became higher, rainfall in the region was reduced, and the forest began to die out, eventually becoming open savanna. The old idea was that upright walking must have appeared after the savanna was formed, a theory enshrined in perhaps the most famous image in the whole of science, the ascent of man. But now, thanks to the discovery of Orrorin, we have the first direct evidence that this picture may be wrong.
The sort of classic image of a quadrupedal ape-like creatures, such as a chimp, for example, gradually becoming upright, going through all the stages of tottering and up to become fully upright. I think that's to be thrown in the wastebasket. I may be wrong, but I really think that idea should be removed from the list of hypotheses about hominid origins.
Orrorin doesn't fit the old theory. The fossil animals found with it show that far from being a creature of wide open spaces, it still lived amongst the trees. And we already know that its finger bones show that it was good at climbing.
One thing that's emerging now, and Orrorin, the discovery of Orrorin really reinforces this, is the idea that bipedalism is an adaptation that arose in a more forested environment and was a pre-adaptation in many ways to when they did move out onto the savanna grasslands.
So, how did it happen? How could a tree-dwelling creature develop what we now consider to be the most fundamental aspect of the human form? How does an ape learn to walk? Robin Crompton from the University of Liverpool is one of the few scientists in the world who is researching early human walking patterns. By analysing one particular modern primate, he may have explained how an upright, forest-dwelling animal like Orrorin came to evolve. The subject of this research is one of the rarest animals in the world, the orangutan.
For us, the orangutan is a fascinating animal, not only attractive, but scientifically fascinating, because it may, of all the great apes, be our best model for the origins of bipedality.
The name orangutan means forest man in Indonesian. And while they don't come from Africa, and they are not our closest living relative, they display behaviour and adaptations that may hint at how we developed bipedalism. Here at Chester Zoo, Robin has been using special high-speed video cameras to film these animals' unique way of walking, which, unlike the chimpanzee, is remarkably similar to ours.
The hip joint is very extended, that is, the leg goes behind the body, and you won't see a chimpanzee do that. And this is linked to their behavior in the high levels of the forest canopy, gathering fruit and moving on fairly small vines and using their body to, rather like almost like a spider, to reach out for branches, to reach out for food.
In the wild, these animals hardly ever come down to the ground, preferring to spend almost all their time 60 meters up in the forest canopy. Yet they often support almost all their weight on their hind legs, and their habitat supplies them with the ideal environment in which to develop an acute sense of balance.
The trees are perhaps the ideal nursery for the evolution of human walking, because they enable an animal to balance itself. They can reach out in any direction. Everywhere, below them, above them, to the side of them, they'll find branches which they can touch. For me then, the evidence is increasingly strong that bipedalism did not arise on the ground, but arose in the trees.
A creature that is basically arboreal but needs to cross from patch of trees to patch of trees, if they're bipedal, they have an advantage. They don't have to change the body too much. They come down to the ground, their bodies are already upright from being in the trees. They cross the ground upright and they climb up the next patch of trees to get food. They don't have to modify the body too much.
So rather than the traditional picture of evolution, this would be more accurate. Our ancestors have been upright for well over 6 million years. After all, Orrerin must itself have evolved from an ape that was to some extent bipedal. Millennium Man was an animal with a unique set of abilities. It could climb in the trees like an orangutan, but it could also walk on the ground like a human being. A set of geological and evolutionary coincidences led to the prototype of the human form, which millions of years later would evolve again into modern man. Frustratingly, the finer details of this extraordinary animal will not be known until more is found. However, the team are still looking.
Hey Brigitte, regarde. C'est le bonhomme, une canine.
Ah!
Hein?
Hey.
This canine tooth is just the latest piece of evidence of the ape that learned to walk.